Let me tell you, few things get more overlooked than backflow prevention. But if you mess this up, you risk contaminating drinking water. Backflow prevention devices are critical and required by code to stop dirty irrigation water from getting sucked back into the public supply. Today we're going to look at what causes backflow, how to prevent it, and the pros and cons of each type of device. Plus, I'll show you some tips to keep them safe and functioning long term. Backflow happens when water in your irrigation system moves the wrong direction, right back toward the water source. Here's a real-life example of pressure gone wrong. My brother-in-law accidentally connected a hose to the black water flush tank, aka sewage tank, on his camper instead of the fresh water inlet, and filled it up. I noticed brown water coming from my kitchen sink and flushed the system, not realizing it was sewage. A few days later, while troubleshooting with a handyman, we saw sewage pouring out of the hose when we turned it on. Thankfully, no one got sick, but ew, seriously gross. There are two main culprits of backflow. Back pressure, where your system creates more pressure than the supply, maybe from a pump or elevation change, and back siphonage, where pressure drops in the public line and sucks water back in, like when a fire hydrant is opened. Either one can pull pesticides, fertilizer, or dirty water into the clean supply, and that's why every system needs protection. Back to my brother-in-law problem. Which culprit was this? If you said back pressure, then you would be right. Let's take a quick look at the key players in backflow prevention. Each one is built for a specific situation, depending on the level of risk and how it needs to be installed. The AVB is your basic option. It works for low-risk setups, but it can't stay pressurized. The PVB can handle constant pressure and is a solid choice for most standard irrigation systems. The DCA is suited for low to medium hazard areas, and it can even be installed underground. The RPA is your go-to for high-risk areas, like when fertilizer is being injected into the system. And finally, the air gap, the simplest of all. No moving parts, just a physical break between the water source and the system. As we go through each of these, I'll walk you through when to use them, where you'll likely see them, and how to recognize them in the field. Atmospheric vacuum breakers, or AVBs, are the simplest option and also the most limited. They can't handle constant pressure, so they have to be installed after the irrigation valves. You'll often see them paired with a valve in one assembly, which we call an anti-siphon valve. These are affordable and easy to install, but they aren't testable and don't work for all layouts. They're also not great in freezing climates since they sit above ground. Pressure vacuum breakers, or PVBs, step it up a notch. These can handle constant pressure, so you can place them before the valves on the main line. They've got two key features: test ports and a poppet-style valve that dumps water out of the top if back siphonage is detected. It needs to be installed above ground, 12 inches higher than the highest sprinkler head. And depending on your local code, it may need to be located close to the point of connection. Now, the double check assembly, or DCA, gives you two layers of protection with two internal check valves. It can go underground if your local codes allow, which makes it great for aesthetic installs. You'll recognize it by the two shutoff valves and the test ports on the top or side. It handles back siphonage and can sit under constant pressure, but unlike the next device, it does not protect against back pressure, so use it only where that's not a concern. The reduced pressure assembly, or RPA, is the gold standard for irrigation systems. The RPA protects against both back pressure and back siphonage. It's got two check valves and a diaphragm that dumps water through a discharge port if pressure drops. This one has to be installed above ground with at least 12 inches of clearance underneath so the relief valve can do its job. It's required in many places, especially if you're using fertilizer injection or dealing with high hazard setups. This one isn't part of the irrigation system, but you will see it in the field. An air gap is a physical break between a water supply pipe and a tank, like on a fertilizer mixing tank or a water truck fill pipe. There's no moving parts here, just an intentional gap to stop contamination. You won't use this in standard irrigation installs, but you do need to recognize it. Now this part is crucial. Even if you install a backflow device, it won't matter if it doesn't meet your local code. Each county or municipality might have different rules about which devices are approved, where they need to be located, and how often they must be tested. Some areas require annual inspections by a certified tester. Others are more flexible, but you should always check. I recommend keeping a relationship with your local water authority. It makes life easier when you're planning a job or getting permits. And one more thing, if a system includes fertilizer injection, most codes automatically require an RPA. Better to be safe than fined, or worse, responsible for contamination. Let's talk about keeping your backflow preventer safe. Because they're not just expensive, they're also vulnerable. Most of these devices are installed above ground and made of bronze, which makes them a magnet for both theft and damage. And I've got a personal story for you. My brother-in-law once backed into our backflow preventer with his brand new truck. He said he felt some resistance, but just kept going. Yep, we made him pay us back. So here's what I recommend. Use protective cages or fake rocks to keep them out of sight and shielded from bumps and thieves. Stake or support pipes properly to prevent tipping and snapping. And if you're in a cold climate, add insulated covers or thermal bags to protect them from freezing and bursting. Trust me, it's way cheaper to protect it now than replace it after a whoops. So here's your quick recap. Backflow is dangerous and preventable. Choose the right device for your system and local codes. AVBs, PVBs, DCAs, RPAs, and air gaps all have their place. And never forget to protect your devices from damage. It may not be the most exciting part of irrigation, but it's one of the most important. Safe water is non-negotiable.